I'm Anil Kumar and now we will discuss limits at infinity. The question here is, find the following limits using properties of limits. Limit as x approaches infinity for 3x squared plus 1 divided by 2x squared minus 1. Now to answer such question, it is better to simplify this or rewrite this function. Let me show you how. So we have 3x squared plus 1 divided by 2x squared minus 1. What we can do is, in the numerator and denominator, we can factor out the terms with x squared, which in this case is, or you can just factor out x squared as you wish, right? So you can factor out, you could do both or your wish. You could do 3x squared. In that case, you get here 1 plus 1 over 3x squared, right? Or you could also factor just x squared. So let me do x squared in the denominator. Both are possible. So just thinking how to incorporate both. These are ways of doing it. So you could adopt this. But adopt the same method on both numerator and denominator. Okay, don't do like I'm doing here. It is only for explanation. So if I factor out x squared in the denominator, I get 2 minus 1 over x squared. You understand? If you would have factored out x squared in the numerator, you would have got 3 plus 1 over x squared, correct? So in this case, I'm trying to show you different techniques in one example. That's the whole idea. Now, once we have this, we could cancel x squared and x squared. And now we can rewrite this function as equals to 3 over, this is 3 times 1 plus 1 over 3x squared, right? Divided by 2 minus 1 over x squared. Correct. So let us say we have all this. So we have actually kind of rewritten the given function in a different form. And now we will utilize the properties of limits to answer this particular question, correct? So I could actually expand, right? And then write down this also as 3 plus 1 over x squared. That's simpler for us to do actually. So the better technique, of course, is just to factor out the variable part, right? And then do the needful. So let us rewrite our function in this form. So we could write this as equals to limit when x approaches infinity. And as you have seen, we could write this as 3 plus 1 over x squared divided by 2 minus 1 over x squared. Correct? Now applying the properties of limits, which sum and difference, and then there is quotient also, I could write this as limit as x approaches infinity for 3 plus limit as x approaches infinity for 1 over x squared divided by limit as x approaches infinity for 2 minus limit as x approaches infinity for 1 over x squared. Now 3 is a constant, so the limit when x approaches infinity will be 3. On this side, if x is very, very large, 1 over x squared is going to be approaching 0, so we have 3 plus 0. In the denominator, 2 is a constant, and therefore the limit is going to be 2. So that is the basic limit. And in this case, 1 over x squared when x approaches very large value will be approaching 0. So what we get here is 3 over 2. So 3 over 2 is the limit of the given function as x approaches infinity. Now the important part here is, whenever you're working with such questions, it is kind of important to factor. And to factor, you could do, this is a better way of doing it, both numerator and denominator, just factor out the x terms and become simpler for you to then find the limits using properties or not, right, as the question may be. I hope this strategy will help you to solve similar questions. Thank you and all the best.